Most of the people that answered this actually got this wrong, and it's quite a hard question, and if you don't realise what you're meant to be doing, it's quite difficult to answer. Magnesium reacts with aqueous silver nitrate as shown below, and then you've got this reaction here. An excess of magnesium is added to 100 centimeters cubed of 0.4 moles per decimeter cubed silver nitrate. The initial temperature is 20 degrees. Determine the maximum temperature reached to 3 significant figures. Assume the specific heat capacity and density of the solution are the same as for water and there are no heat losses, for a total of 4 marks. So the first thing you should do is underline all the main numbers. So that's the main number there, there, and there. And so that's 4 main numbers you should underline before anything else. And then you've obviously got the equation there. So the first thing you need to figure out is that the maximum temperature is what you're trying to find out, and you know that silver nitrate is causing that change in enthalpy. And so first thing you need to do is work out the moles of silver nitrate, and you know that that's equal to volume times concentration, like so. And this is equal to 0.1, which is 100 divided by 1000, times 0.4, so they're all in decimeter cubed, equals 0.04 moles of silver nitrate. So now what you need to do is figure out where do you go from here. So you know up here is the change in enthalpy, and that's 678 kilojoules per mole. So you need to figure out how much energy is released per mole. And so, 678 times 0.04, so that's the amount of energy per mole, but you have to divide it by 2 because of the stoichiometric value. You have to divide it by 2. And that means it's per mole. So you have to divide that by 2 to then get this equation here. So this is going to be equal to 13,560 joules, which is good. So now we've got the energy released per mole, and now we can use the equation Q equals mcΔT, which is fine, which is basically what all of this is about. And you want to rearrange for that because we want that. So delta T is equal to Q over mc, and we know that Q is equal to 13,560 joules, which is good. M is going to be equal to 100, just like so, and then C is equal, 100, it'll be 100 because the density is kept the same. It's the same for water. The density of the solution is the same for water, so therefore 100 grams. And heat capacity is also the same for water, so that's going to be 4.18, so that's fine. And then delta T is equal to 13,560 divided by M times C, so 418. And this will give you an answer of 32.4 degrees Celsius, which is the delta T. We do, however, know that the initial temperature is 20 degrees, and as this is only the change, you need to add that on. So 20 plus 32.4 is equal to 52.4 degrees Celsius, which is your answer. 4 marks. Thank you for watching.